Hi everyone! Today we are going to finish the exercises about either and have some discussions around the modelization of errors. Let's open the file either exercises 2 in the package exercises.errorhandling.either. We have one function left to implement at the bottom of the file called validateUser. So validateUser takes two strings representing the user's input that we collect from a web form. The first string is the username, and the second string is the country of residence. So the goal of validateUser is to check that both inputs are correct according to the function validateUsername and validateCountry that we implemented previously. If all the inputs are correct, then validateUser returns an instance of the user class. Otherwise, it returns an error. As you can see, the return type is commented out. It is up to you to decide which type we should use on the left of the either. There are a couple of possibilities. We'll go through each one of them and discuss their pros and cons after you give it a try. So please pause the video and try to implement validateUser. Okay, so let's try the simplest solution first, when we'll use the for comprehension to combine the two validations together, and we'll see what we get. So first we'll call validateUsername, which will give us the username. Then we'll do the same for country, which will give us the country of residence. Let's say validateCountry, take the country string. And then in the yield statement, we'll combine both username and country inside of a user. So here we'll say username country. And this will only be called if both validations are successful. Exactly what we want. Now, as you can see, Scala infers an error type which is either object user. So Scala infers object as the error type. Object is the top level type in Java, which corresponds to any ref in Scala. So if we want, we can rename this type to any ref. It's the same thing. Now, why does Scala infers object or any ref? As we have seen in the previous video, the result of a for comprehension is an either with an error type that corresponds to the least upper bound of all error types within the for comprehension. Now we know that validateUsername returns a username error and validateCountry a country error. And these two traits, as you can see here, are completely unrelated. So the closest parent they have in common is AnyRef, the parent of all references in Scala. Now the problem with AnyRef is that it is quite imprecise. It doesn't give us much information about the type of error that can occur. So how can we improve that? I'll let you pause the video and think about it for a few more minutes. There are a few solutions. First, if we were using Scala 3, we could use union types to encode the error. For example, we could have said that validateUser returns an either with an error type username error, pipe, country error. This pipe between the two types means OR. This works out of the box in Scala 3, because when we take two types A and B, then A pipe B is automatically a parent of both A and B. Actually, A pipe B is the least upper bound of these two types. I believe that this technique will be quite useful in Scala 3. Time will tell. However, it may lead to complex signatures when it's used with too many types. For example, it's not really readable to have a method that returns an either of country error, pipe username error, pipe address error, pipe date of birth error. One way to sidestep this issue is to create a type alias for common unions. For example, we can define user error to be equal to this very long union of types. Great, so I believe union types are going to be a good option for combining errors, but they are only available in Scala 3. If your codebase is in Scala 2, as is the case for the course, we need to find a different approach. Instead, we can create a top-level error trait. For example, we can define a new seal trait called user error, and then update username error and country error so that they both extend user error. In other words, we are creating a sort of a pyramid of error types, and we let the type inference figure out the least upper bound for each function. For example, if a for comprehension produces a too small and country error, then the least upper bound is user error. But if a for comprehension produces a too small and invalid characters error, then the least upper bound is username error. So this approach works, but it's quite cumbersome, because we are creating an enumeration per function and a complex type hierarchy. It's time-consuming and difficult to manage. That's why I recommend that if you go for this approach, you limit the hierarchy to a maximum of 3 levels. 1 at the top level application error, common to all errors within the application. 2 a middle layer with an error type per subsystem, such as validation error for input validation, auth error for the authentication layer, and maybe 1 error type for each domain of the application. Finally, at the bottom of the hierarchy, there are the concrete error types. Each one describes a particular failure. So if we apply this to our exercise, it means that we should get rid of username error and country error and move all concrete error types to extend validation error. Let's try it out. So what we can do is to rename country error to validation error, and then basically merge the 2 traits together. So now we don't have any username error and country error, we just have validation error. Now whenever we used username error, actually this we can keep it, and whenever we have country error we can get rid of it. Now we need to change the imports here and in the test as well. So here we're going to say we need to import all the errors. So let's see if it compiles, and let's run the test. Yeah, it works. So as you can see, it wasn't such a big refactoring, though it's not perfect. With this encoding, we lose a little bit of precision. For example, validate username now returns a validation error, even though it cannot produce an invalid format error. That said, I believe it's a good compromise because the errors are simpler to define and we don't have to deal with a complex hierarchy, and it's simpler to use. Okay, so if you haven't done so yet, please write some tests for validate user. So at the moment they were non-defined. And just to check that it behaves as expected. Okay, so let's give it a try. We can first verify that when both inputs are correct, we get back a correct user. Basically, we get a right. So what about the countries? FRA is for France. Now we say, okay, if we get these inputs, we expect to get a user with a username Bob something, and the country France. Yeah, did I miss some parentheses? Yeah, sorry, it's username, I needed to close it. Yep, let's run the test to see if it works. Yes, it does. So this is a nice thing about having dealing with either. We're just dealing with value, so it's relatively easy to test. Now we can do the same with an invalid user. So for example, if we say Bo, we know that Bo is an invalid user because it is too small. So we can say this we expect to get left of, sorry, what is it, too small, of 2. And if we do the same with an invalid country, so for example, if we put, let's say Argentina, like Arg, we expect to get again a left, but this time with not supported, because Argentina is not supported in our application. So let's run the test. Yeah, it works. So everything works as expected if both inputs are correct and if one of them is invalid. Now what should happen if both inputs are invalid? Let's check the implementation. So if both inputs are invalid, we should only get an error about the username This is because we compose the either using a for comprehension, which means that the code stops executing as soon as the first either returns a failure. A for comprehension must behave this way because when we call validate country, like here, we have access to the username. So if we have access to the username, it means that the username string must be correct. There is no other way. Let's verify this with a test example. So let's duplicate this test. We say, okay, let's imagine that both the username is invalid and the country is invalid. Now I believe that we should get this error. Let's run the test. Cool, so it works as expected. We only know that the username is invalid, even though both inputs are wrong. This may not be the most user-friendly behavior. Ideally, we would like to report all fields that are invalid so that the user can fix them all at once. Here, it doesn't matter too much because we only have 2 fields. But imagine if we have a longer form with dozens of input. We wouldn't want to submit the form, get one error, fix it, submit the form again, get another error, and so on. It's really not friendly. So I suggest that we take a break for now, and the next video will work on how to accumulate errors. See you soon!